All right. So let's start. Okay, right. I think we still need to go through one more worksheet from here. Toilet. Okay. All right. So let's go through this one first. Just to do a quick check on your answers. Okay, so question one, mass number of an atom is defined as the total number of neutrons and protons. So it should be A. So answer is A. I'll just circle those answer here. So it's B. And for question two, neutral species of Ca contain 20 neutrons, 20 protons, and 20 electrons. So it should be B, right? I think let me double confirm with this. Just give me a second. Okay, where are the rest? The rest not here yet. Okay, right. Then the second one is going to be C. Question two is C. Question three. Question three is on the X, Y, and Z are given below. And number of protons, these particles are, number of electrons are 10. So 10 will generally give you, so they could be ions. They could be either anion or cation, because you can see that when the number of protons are different, while the number of protons are different, they have the same number of electrons. So in terms of number of protons, we can see from here that some of them are metal, some of them are non-metal. So this is generally non-metal. What can you say about this? Question three. So they have more protons than electrons. So they should be what ions? Cations. 98 protons and 35 neutrons. So if we are going to add these samples, it's going to be a copper. So when you add up, it's going to be. Please check along question 5. The electron configuration of an atom of phosphorus. Phosphorus is 15. So 15 should be 3s2 and 3p. Sorry. It could be a 10. It's D. What about 6? 27 protons, 20 neutrons, 25 electrons. So you have a lesser electrons than the proton, so it should be a positive. Yes, positive ions. So it will be A. Then the next one, the number of neutrons in an atom. The neutron will be 197 minus 179. What do you get for that? I think it's over 18, right? 197 minus 118. This one is chapter 1, multiple choice questions. 4 particles are described in the table. Which of the following pairs of the particles are isotopes? You didn't bring them? It was given like the week before. 1 and 4. So 1 and 4, they have the same number of electrons, but they have a different. Oh, wait, sorry. 1 and 4. 2 and 4. Atomic number. 2 and I think it's 2 and 3 because they should have the same atomic number but different mass number. So it should be 2 and 3. Okay. Question 9. Excited, then look at a neutral atom with its electron in an excited state. So how do you define whether they are in an excited state? The one in the one. So why is it C? Atomic number is 9. You have a extra of 1 electrons there, right? The other things are all in there, yeah, right. Atomic number is 9, but you have altogether 10 here. 10 electrons here, so you should see. What about 10? 3D subshell can take a maximum of 10 electrons. Question 11. Same electron configurations of a magnesium ion has a charge of -2 is oxide. Oxide ion is O2-. We'll look at more about these ions today. Question 12. Bromine and then iodines are placed in the same group in the periodic table because they have the same outer shell electrons. Yeah. 13. Have a similar chemical properties with an atomic number 16. 16 is a group. The 13 is selenium. So on the oxygen. 14. Going down group 1. Lithium from this first ionization energy. First ionization energy. B decreases, atomic radius increases. Question 15. Properties of an element with to produce a modern form of periodic tables are. Yeah, configurations. (16) atomic radius Na to Ar increases, first ionization energy decreases. 17. Increase across the periodic table form from sodium to chlorine. Which one increases? If you go from left to right in a period, atomic radius decrease or increase? Decrease, right? If atomic radius decrease, you have a higher nuclear charge. So your ionization, first ionization energy increase. Okay, because atomic radius decreases, so first ionization energy will decrease. Your nuclear charge will also increase. Which of the following have the largest radius? Beryllium, calcium, magnesium, strontium, they are in group 2. As you go down the group, atomic radius increases. Which one is at the bottom? Strontium, right? This one you can refer to the periodic table, it's easier to look. 19. When going down group 1 from lithium to cesium, which one of the following statement is correct? Lithium to cesium, first ionization energy increase? No, not really. Atoms are more likely to react to form 2+ cation? No. Become more reactive. Attraction between the nucleus and the outermost electron increase. Which one? But they're the same. Attraction is weaker, right? Because first ionization energy and these two are related. It should be C, become more reactive. 20. This one is very obvious. So answer for 20. Only a non-metallic elements is B, right? Because this one is a metal. This one are metals. These are all metals. These are metals. Will have a smallest radius. Smallest radius are on the other side, and then at the top. Yeah. Really? Chlorine or potassium? Wait, which one? Question 20 or question 20? 21, yeah. Sorry. Minus is going to be yeah, near. And potassium plus will also be on. So okay, if I'm going to look at like potassium and you have to compare. Okay, definitely you have to compare with sodium and fluorine. Which one do you think is going to be smaller? Because they will have the same number of shell. First of all, they will have the same number of shell compared to the sodium and then fluorine. So generally what you have to do is you have to compare these two. Which one will be smaller? So if they have the same number of shell, what do you have to compare? Yeah. One more that is going to attract this outermost electron. Nuclear charge. Okay, how many protons? Because they have the same number of shells, they have the same number of electrons, so their electron repulsion is the same, right? So they also both of them have a two shells. The electronic configuration of this is also 2,8. This is also 2,8. Of course, these two will not be involved. You have to compare these two. But when they have the same number of shells, this one have a 11 neutron. This one has only 9 neutron. Which one will actually be pulled towards the center more? So it will be sodium, right? So it should be this, not this. Okay, be careful this. Okay, next, which one of the have the largest radius? Largest radius is quite obvious, right? Potassium active. The first 8 ionization energy of elements are shown in this. So first ionization, second ionization, third, fourth, and then go on. So generally, after you remove 4 electrons, then there is a big jump in it. So what do you think could be which element is most likely? Neon, because after it remove 4 electrons, there's a big gap. That means it should be something like 2s2 and 2p2. It should be in group 4. So sorry, group 14. So group 14, there are 2 group 14, carbon and silicon. It should be silicon. Why is it silicon? Because if it is a carbon, generally, it's going to can you reach up to here? No, right? You only have a 6 electrons, so you won't have this much for carbon. You have something like this coming out from, I don't know where the other 2 electrons come from. So it must be silicon. 24. Noble gas, of course, is going to be this one, right? Because noble gas cannot be a D, because noble gas is a P block. So P blocks is either ending this or this. You can't end with D. This one also no. So it must have a full structure. So it will be B. Okay. All right. Is that okay? Okay. Any question regarding this? Okay. If not, okay. Should have actually wait. I think I close it properly. Okay, today I'm going to start on this this one. It's about ionic compound. So ionic compounds generally is based on the formation of ions. Okay, right. So they will generally be formed when the ions are formed. So there are a few points that we will be revising a little bit first before we move on to the key information. So learning objective, let's look at the learning objective for this particular chapter. In these notes, we have covered up to here. The 3 points are covered in these notes. The rest, the fourth one, I think I'll give you next week. We will look at like precipitations, reactions, which is whether a certain kind of ionic compound will be able to dissolve in water or not. And we are going to look at the properties of that solubility in very much details in the next chapter as well. So solubility part is a big chunk. After this, chapter 5 is about solubility through water as well. Then after this, chapter 5, we are done with unit 1, US 1. Then we'll have a US 2. After US 2, then we'll do like bit of an investigation task. We still have about how many more weeks for this year? Guess I want to give something for you to do during the holiday. It is 19. So 1, 2, 3, 4, 5, 6, 7, 8 weeks. Yeah, I should be able to finish US 1. Then after US 1, we'll have a bigger test on it. Then afterwards, we will have I'll give you something for you to do as a holiday. Okay, right. Key points: formation of ionic compound through so you need to recognize that the formation of ionic compounds are due to the transfer of electron. Remember in the previous chapter 3, when we look at covalent compound is a sharing of electrons. So here is a transfer of electrons. The transfer of electron will always go from metal to non-metals. So the electron will be, so this metal will be forming positive ion, non-metal will be forming negative ion. Then we should be able to write down ionic compound formula and also containing polyatomic ions. So these are your polyatomic ions that we are going to look at. And we will be looking at how these polyatomic ions are formed and why do they get these kind of a charge here. So then this 2 part where the formula and name of the ionic compounds will be covered in chapter 4A, 4A. And then this is going to be 4B. I think today we could only do 4A. We may not be able to cover 4B. So please do not forget to bring back that note next week. Okay, ions, of course, either loss or gain of electrons to become more stable. Of course, ions are supposed to be more stable. Okay, so when they form compounds, they are supposed to be more stable. So that means the one that you get is something which is not less stable, because they will either lose or gain electrons to get a full electronic structure as the noble gases. When atom lose electrons, the results are now more protons, so it will have a positive charge, so they are called cations. The general structure of a potassium, like sodium cation, is given here when you lose these electrons. So once you lose, normally what do you do is you will represent this one as a plus here. So can you put this like square bracket and put a plus there on the diagram? This is how you represent generally. And in most of the case, they will not ask you to draw all the electrons. They will only ask you to draw the outermost shell. Okay, so which means that you don't need to draw like those lower shell, and you also no need to draw like those like nuclear charges here. But what you need to be able to do is to be able to understand what is the kind of a charge that you're going to get. Same thing goes for calcium. So in this case, since you are losing this two, then you will get 2 plus here. You need to be able to write down the 2 plus here. So when atoms gain electrons, the results are that now they are more electrons, negative charges. So therefore, their overall negative charges exist. So they are called anion. So this is just it's a kind of a way to just remember if you get always confused between anion and cation, because anion and cations are important terms. In unit 3, when we are focusing on galvanic cell and electrolytic cells, and when we talk about all these things, you will be seeing cation and anion very commonly then. So you will have to be able to use what is cation, and is it positive? Is it negative? You must always keep in mind that they say cat has paw, so that means it's a positive. It's just a way to remember. Okay, onion make you cry. Have you ever liked a sliced onion before? Never? Okay, so when you go back home, then you try to help your parents with something. So it's like when onion make you cry, that means it's sort of like negative emotion. So onions is anion is like negative kind of things. All right, it's just a way to remember, kind of like a mnemonic, not a mnemonic. It's just an analogous way of remembering things. So cat have paws and onion make you cry. Just remember this too. All right. Anyway, chloride ion. So in this case, you have an addition of a one additional chloride electrons is being added here. So which is this one. Because of this, your overall charge, you put a square bracket and then put a minus here. Sulfide, same thing. You have an extra of this and this coming in. So in this case, you should be able to say that it's going to be a 2 minus. And we do not write down -2 or like -1. 1, we do not write down the value, just put a minus there. And then for all the ions, the sign will be used as the last one, so that you don't get confused with the others. And if we are going to compare the periodic table for a particular groups, those like group 1, group 2, group 13, 14, 15, 16, 17, 18, they will form a particular cation and a fixed anion. Okay, so which means that in group 1, you're going to lose 1 electrons to be able to form into a stable electron structure. So all the group 1 will be 1 plus, and group 2, all the group 2 will be 2 plus, Then we will skip all these things. We will talk about these transition elements later because these are D blocks. Because D blocks are a little bit more problematic. The reason is that D block will also be dealing with an S. Because just before that is we have an S electronic S orbital here. Then D orbital and S orbitals, they will always match between their energy level. So the reason, because of that, these D blocks elements will have like a variable or like multiple, what we call it, ionic structure. Okay, multiple like sort of like charges. Then when you look at group 3, it will always be 3 plus. Then we have from here onward, group 14 onward, this side is negative. So 3 minus, 2 minus, and 1 minus. Right, so this is something that we need to be able to recognize. So just recognize 1, 2, 3, 1, 2, 13 will have a 1 plus, 2 plus, 3 plus. Then the other side, starting from like this halogens, group 17, this is minus 1, this is minus 2, this is minus 2. Because you need to gain 3 electrons. Is that okay? So, and there is a certain group which do not form any ions, is of course your group 18. Okay, so forming ionic compounds. So ionic compounds are those substances composed of both positive and negative ions. Which you need to recognize this. They have both positive and negative ions. This occurs when a metal So a metal will always lose its electrons and transferring them to the non-metal atoms. Then the results will form both cation and ion. Then they will form these ions. Okay, you need to recognize this particular phrase or sentence. These ions arrange themselves onto an overall neutral three-dimensional lattice structures of alternate cation and anion held together by strong electrostatic force of attraction. So this is this is a kind of like a description for the ionic lattice. So if they ask you to describe ionic lattice structure, then you have to use this sentence. So ions in the ionic compounds arrange themselves into an overall neutral. Overall neutral must be included. Because overall neutral means as a holdings, the total number of positive ions and negative ions are the same. Okay, so you need to be able to use this sentence to explain or describe your ionic lattice structure. Is that okay? Question so far? Sure, no. So as you can see in the diagram, you have, of course, sodium is a positive ion, chlorine is a negative ion. Chlorine is much bigger than, sort of like in terms of the size, it's bigger. So when you draw, it will sort of like your positive and negative. This is generally an alternate three-dimensional structure. So generally, you should be able to draw similar to this. If you can't draw like something like this, you should be able to draw at least like minus here, plus here, minus here. So plus here, minus here, plus here. So it's like a 3D shape. So you will get a minus, plus, minus, plus, plus, minus, plus, minus. So in this case, at least you should be able to draw in 2 dimension like this for the alternate structure. Okay, so each row, when you get a plus minus, the other one will be minus plus, then plus minus minus plus. So in 3 dimensions, any positive ion surrounding 6 atoms will be opposite charge. Then the next one will also be the same. Is that okay? Okay, so this is generally about the sodium chloride table salt, the one that you eat every day, okay? And of course, you must also know how to draw this electron transfer diagram. So in the electron transfer diagram, generally what is more important is for you to be able to draw this part. It is okay if you can't draw. I mean, rather they will not ask you to draw this. They will ask you to draw this. So you should be able to draw this. Okay. So what happened is that sodium has a group 1. So it will have a 1 electrons that is going to be transferred out. You will transfer out this. For sulfur is 6. So you need to have a add 2 electrons to it. So 1 electron will come from 1 sodium atom, another electron will come from another sodium atom. Then you have to draw it. But normally when you draw in the exam, you don't need to repeat this again. So what you do is you don't draw this way, you just put 2 here. You just have to draw once. If they ask you to draw the like electron transfer diagram or like basically using dot and cross diagram, you just have to draw once and then times twice. Okay, and then because that will give you a 2 plus, this is going to be 2 minus, then your overall structure must be 0. So this is the expected of you for you to be able to draw these like electron transfer diagram. All right? Oh, what happened? So big. So they say draw an electron transfer diagram will happen to the sodium and oxygen atoms react together. So sodium, if you are going to look at like sodium initially is 281. So you're going to lose this, so it will be forming an A plus. For oxygen, it is 2, 6. So you need to add 2 electrons to it. So which means it will form 2 minus. So which means you need a 2 sodium. So 2 sodium is, you just have to write down Na here. And then in the outermost shell, you will have 8 electrons. So I'm going to use dot for sodium. So since you lose 1 electrons, it will be just plus, and you will need 2 of them. Okay. Then for the oxygen, then your outermost shell will have maybe a cross here, cross. Then you may have a cross and dot here, and cross and dot here. So in this case, the dot comes from sodium, so it must be a dot. Cross is for oxygen, 2 minus. So of course, in terms of the molecular formula or like the formula is going to be NH2O. Okay. Explaining the difference between anion and cation. The main difference is the number of whether you are losing or gaining. So anion is formed when you gain electrons. Gain electrons. Um, Okay, can you try to draw aluminum and oxygen react together? Let's try. How many aluminum, how many oxygen will you need? Aluminum is 283. 283. So you can lose 3 electrons. Oxygen is 26. So this one you can lose 3 electrons. And this one need to gain 2 electrons. So how are you going to match this? How many aluminum will you need? How many oxygen will you need? Yeah, 2 aluminum. And because we try to find the common particle. Okay, so in this case, how do we generally consider is this one times 2 and this one will times 3 because total number that you're going to lose is 6 electrons. Here will also be a 6 electrons. So this two should be the same. So we try to find a common multiple. So in this case, aluminum. So we are going to draw only the outermost electrons. You will have 8 electrons in the outermost shell. And that is forming what we call it 3 plus. You need 2 of them. And with oxygen. And then you are going to have so 3 minus, then you have 3 of them. So in this case, they will form AL2O. You don't really need to write this down. I'm just writing it down just for me to generally like train you how to form write down and tell you what formula it is. Okay, naming and writing ionic compound. Of course, some certain rule for naming ionic compound is that so the name of the metal ion is placed first in the name of the compound. So its name will not be differ, but those name of the non-metal will be placed second in the compound, and then they are going to change the suffix to IDE. So oxygen become oxide, sulfur become sulfite, and chlorine become chloride, nitrogen become nitrate, phosphine become phosphate. So you will have something like lithium chloride, magnesium nitride, aluminum phosphate. Okay, so you just have to understand that you are just adding. You remove the last portion and then just add ID back. That's how you're going to name. Okay, write an ionic compound formula for magnesium chloride. What will be the ionic compound formula for magnesium chloride? How do you determine that one? Anyone have the answer for this? Magnesium is in group. You can refer to your periodic table. Magnesium is in group 2. Okay, and chlorine is in group 17. So magnesium, okay, now let me teach you how to do it. Magnesium is in group 2. So what is the ion that is going to form? Metal is so group 2 means 2, right? Plus or minus? Yeah, cation. So it's going to be 2 plus. For chlorine is just minus, right? Because you're going to gain 1 electron only. So then what you do is you will cross these two together. So you will get MgCl2. So when you put this from this power change to the what we call it subscript, So this value will go to the subscript up here. This value will go to the subscript here. So it will be your NgCl2. Just now, when you look at aluminum, how do you get aluminum? Aluminum has a 3 plus, oxygen has a 2 minus. So when you actually swap, you get Al2O3. Wait. Is that okay? Naming is no problems. What is it? This is sodium sulfite. Last time they used PHID. Now it's you can use FID. Also. Magnesium oxide. And this one is lithium nitrate. Write the chemical formula for the following ionic calcium fluoride. Calcium is Ca2 plus. Fluorine is F minus. So when they cross, you will get CaF2. Potassium bromide. This one is 1 plus. This is 1 minus. So it's going to be a potassium bromide. It's just KBr. Magnesium phosphide. Magnesium is 2 plus. Phosphorus is 3 minus, is it? In the periodic table, which group is it in phosphate? 15. So 15 is 3 minus. So 3 minus. I'm going to cross this. It will be a Mg3P2. All right, any questions? Then moving on to this. Okay, what will happen if we are going over to not group 1, group 2, or group 3? If we are trying to focus on our transition metals, what is going to happen? Okay, let's look at what is the issue with this transition metal. So if we are looking at the transition metal, internet connection unstable. Okay, right. Now let's wait for a while. Okay, now it's transition metal located in the D block. So D block has a little bit of they are mostly lustrous, hard, and strong substance with high melting and boiling point. We'll look at the transition elements a little bit more details later. Most transition metals can lose a varying number of electrons. So they can lose varying number of electrons because of the presence of D blocks. Because D and S blocks, this 3D10 and 4S2, for example, in period 4, their energy level is very close. So that means when the electron lose, the electron can be lost from either from a D block, or it can also be lost from the S block. Or it can also be lost from the S orbital, 4S orbital, or 3D orbital. It can lose from both because their energy level, the energy required for them to lose is quite close. So in this case, for example, like to do with their subshell electron configuration, relative energy of these two kinds, which are quite close. If, for example, if you look at like copper, but it's an exception to the statement above, has a subshell electron configuration of this. So in that case, if you're going to lose, you can either lose this. Okay. So as a metal, copper loses 1 electron. If you are going to, so in this case, it's going to be a copper 1 plus. So this is what we call it. We call this one as copper 1. Okay. And so 1 plus, but most common ion for copper is 2 plus. That's why we call it copper 2 ion. We write down something like this. One of the most common compounds that we can find for copper 2 compound is the blue color one. What is it called? Blue solution. Seawater. Is the seawater blue? But is it blue because of a certain thing? Actually, no. When you actually try to put it in a pail, whatever it is, it becomes like colorless, even for the seawater. Why the seawater is blue? In some area is green. And then even like in some place they have a blue and green like side by side. Well, where is it? It was in a picture. I don't know where it is. Somewhere in the Pacific, right? Huh? Yeah, it's a copper disulfide, but what I'm trying to say is the seawater is nothing to do with the dissolved salt here. It's just because of the reflection from the top. It's because of the light. Okay, it's called what we call it refraction of light and dispersion of light. It's more like polarization of light. So here in this case, copper disulfide. Copper sulfate is a very common, it's a blue color salt. Okay, so this is the blue color salt. But next chapter, we will talk about this salt in very much detail. Why is it blue? Is copper sulfate, can it be a white color? Have you ever seen a copper sulfate, white color copper sulfate in school before? Yes, it can. You try to heat it. You try to heat to a strong, then when all the water goes out, it becomes no longer forming a crystal. When it's changed into powder, it will be white. So that's what we call it anhydrous salt. So we'll talk about those hydrated salt and hydrous salt in the next chapter. Okay. But anyway, okay. When it loses 4s electrons rather than 1, and then 3D now become 9 electrons. Because 4s subshell is of the lower energy than 3D subshell. So they will lose 4s first. Then afterwards, it will form like another 4s coming in. And then you have a 3D. So it will be something like you do not have after 3p6, then you have a 3d9. Your 4s is completely gone. So in that case, you will have a 2 plus. Okay. So 3D subshells, when the orbitals are empty, but orbital began to occupy relative energy change. Okay, but anyway, so this is what they are trying to say, copper 1 oxide and copper 2 oxide. So copper can have 2 different ion. It can form 2 different, but this is more common. Okay, they say determine the charge of a transition metal ions of chromium oxide. So chromium oxide, which one is a transition metal? Definitely oxygen is not metal. Obviously, chromium is the metal. So how are we going to decide? In oxide, oxygen is always 2 minus. Okay, so you have a 3 oxygen, so that means 3 times minus 2. Then we need to find what is the charge of this one. So probably X times 2 for the chromium. If you add up together, what is the total charge of a compound? Any compound, what is the total charge? 0, yes. So total charge, just we need to remember this, total charge of any compound or atoms or element is 0. So which means it's like mass here. So if you do this, what do you get for x? Plus 3, right? So that means it is a CR plus. CR has 2. You have a 6 and 3. There are 2 valence, 2 charges. Here in this case, this is how we find the charges here. Is that okay? Do you understand this, the way of thinking, and then do the formation of the equation? You just have to recognize that oxygen is always 2 minus. Oxygen, of course, oxygen can be just 1 when you have a, in a certain situation, something like what we call it hydrogen peroxide. Okay, but peroxides are very, is quite unstable and less common. So whenever that you are looking at oxygen, we need to consider its charge as 2 minus all the time. So oxygen is very strongly 2 minus. So it's 2 minus, there are 3 oxygen. So multiply with this, you get a plus. In this case, you will get here as a minus 6. So minus 6 go to the other side is plus 6. I believe you are able to follow this particular equation. So what we are trying to do is minus 6 plus 2x equal to 0. So 2x is equal to plus 6. So x is equal to 3. So that's why the charge of a chromium is 3. Make sense? If you know, you don't need to, but it's just trying to. You can also do the crossing, yeah. But when you do the crossing, the problem is that, okay, so when you try to do cross, then you get a Cr and O2. But if the oxygen doesn't have a 2, then you cannot take like this 3 directly. In the simplest form, you can just go back and do the cross it back to do it. But in some situation, for example, like Cr2O7 minus. So what this are later on we'll talk about. This is what we call it polyatomic ion. It's called chromic ion. You will see this one in many different places because this is a very common oxidizing agent. Whenever in organic chemistry, in any oxidation reactions, you will see this one very commonly. But in this case, is it 7 plus? You can't do it. So we have to do something more structured way of thinking in this case. Okay. All right. Okay, ion can exist with 2 different ionic charges. Yes, 2 plus and 3 plus. Write the formula for each of these when combined with chlorine. Write the appropriate name to distinguish between them. So chlorine is 1 minus. Is 1 minus. So Fe can be Fe2 plus and Cl is minus. If you cross, you will get a FeCl2. So this is called ion 2 chlorine. We use Roman letter to represent their respective charge. Okay. Iron 3 chloride. And here we have a Fe3 plus and Cl minus. If you cross, you will get a FeCl3. So this is called iron 3 chloride. Okay, now let's look at this. Here is quite simple in the sense you can do a cross. So Zn3P2. So if I'm going to cross it out, you are going to get Zn2 and P3. So we know that P is 3 minus, obviously, so it should be a Zn will be 2 plus. In a simple case like this, we can do like a cross methods to do it quickly. Okay, naming and writing chemical formula for ionic compound with a O. I think something missed here. It should be a polyatomic. Okay, let's try to analyze this particular term. What is poly? Poly mean many. You know polynomial, right? Then atomic mean atoms. So when an ion contains more than one atoms, previously we have Zn2 plus. This is monoatomic ion because you only have a one atom in it. Zinc or iron or copper or sodium, potassium, whatever it is. But when you have more than one atoms combined together, it becomes polyatomic ion. Just now we look at like Cr2O7 minus. This is what we call it polyatomic because you have a two. And we can have something like HCO3, which is what we call it hydrogen carbonate, HCO3 minus. Then again, this is polyatomic. It has a three atoms each in that particular ion. Okay, so what we are going to do is we are going to look at these things here. So, right, so here in this case, your polyatomic ions consist of more than a single atom covalently bonded together to form a charged compound. In between them, okay, for example, like Cr and O, or like H and carbon. Okay, the simplest one maybe we can look at is NO3 minus. Okay. N and O, the things between them are just something like this. Okay. It's a covalently bonded, but what happens is that when different elements are present, the atom combines the fixed ratio. That one is. However, occasionally, a particular molecule loses one or more H plus ion. So the electrons are left behind on the central atoms of the molecule. Then you will be producing a negative charge. So normally polyatomic ions are mostly common in anion. Okay, there is only one cation which is polyatomic, which is, or rather more common one is what we call it NH4 plus. This is what we call it ammonium ion. Other than that, the rest are mostly anion. Okay, most of the polyatomic ions are. They become an ion because those in that particular compound, you lose one or two. You lose one or two. You lose one or two hydrogen. For example, like, let's look at this. We have a compound called H2SO. What is it? Do you know what is that? It's sulfuric acid. Okay, then this sulfuric acid, when you lose hydrogen, it will become what we call it HSO4 minus, which is what we call it hydrogen sulfate. And then when you lose like minus one H plus ion, you lose another H plus ion, that would be SO4 2 minus. This is what we call it sulfate ion. Which is also a polyatomic ion. Okay. But these ions behave as a single entity. So that means you cannot add them or like separate them as a 2 different atoms. You have to consider as a single entity. So when you name, we must also name as a single entity. Okay. So there is more than one of these ions present in a chemical formula, then we must use a bracket to place it along. Okay, we'll talk about this later. For example, what I'm trying to say is, let's say copper 2 nitrate, which means that we have an NO3. This is what we call it copper 2 nitrate, because copper is 2 plus, NO3 is just minus. So you need 2 of them together. I will give you copper nitrate. So whenever you are writing down in the chemical formula, you have to use the bracket to represent them as a single entity. Okay, one of the common polyatomic ion is hydroxide. Okay, sodium hydroxide is your caustic soda. It's the one that you use in your bakery. Okay, so you also, if you eat bread, then you are eating that one as well. And then it's also included in as a detergent, partly. So it's like, yeah. Sorry, this one is sodium hydroxide is in detergent. So when you do the cleaning, floor cleaning or like toilet cleaning, whatever it is. So here in this case, sodium hydroxide, write the formula for this. Sodium is Na, which is plus, OH is minus. So, okay, then you will ask me how we're going to do this. Okay, later on, I'm going to give you this table. So in this case, you will be getting like the OH. So if you do not need any multiplier, you don't need a bracket. If you need a multiplier, then you need to put in a bracket. Magnesium nitrate, again, magnesium is 2 plus. Nitrate, which is a single entity, is considered minus. So when you cross, you should be able to get magnesium nitrate. Twice. Oops, what happened? Internet connection. Okay. Nothing wrong. Hello. What's wrong with this? Screen is still loading. Okay. All right. So this is about magnesium sulfate. All right. So this is. Oh yeah. Get distracted by. Okay. So this is all the things that we need to do. I didn't put in the. Oh, I think I forgot to write down those polyatomic ions. Okay. I should have actually given you. Okay, maybe I'll just write down those common polyatomic ions. Common ions. We have a NO3 minus. This is called nitrate. We have a SO4 2 minus. What's wrong? Oh my gosh. Okay, SO4 2 minus sulfate. Then we have a CO3 2 minus. This is called carbonate. And we also have a OH minus, which is hydroxide. Internet connection unstable. Okay. Then we also have what we call it hydrogen carbonate. CO3 minus, before we call it hydrogen. We also have a HSO4, not very common, but it's also have a hydrogen sulfate. And yeah, we have a NH4, which is the ammonium ion. This is the only cation ion. I'm not like enforcing you need to, but you will get used to them after a while. Uh, Anything else? Hydroxide, sulfate, nitrate. Yeah, we have what we call it chromate, magnates. Well, we'll do like slightly because you can have a different valency, different. Defining the following terms, I will leave it up to you. You can just refer from the textbook, or I mean from the notes for you to define. So I'm not going to answer them. Let's move over to this. This one I can also. Okay, subshell electron configuration for nitrogen is what is a subshell? Let me look at the periodic table. Or rather, I'll just put it this way. So it's going to be a 1s2, 2s2, 2p3. One more valence electron is 5. So when it becomes 8, you are going to gain 3 electrons, so which means it's going to be a 3. Oh, sorry. It is the way that they say what does it become? What does it become? So it's gain 3 electron. Charge after gain or lose, so it's a plus, sorry, -3. So its symbol should be N3 minus. They're looking for this. Okay, fluorine. Fluorine is going to be a 1s2, 2s2, 2p5, then 7. Oh my gosh. So you need to gain 1 electron. It's going to be a sodium. That means 2s2, 6, 3s2, 3s1. So number of valence electron is 1. You need to lose 1 electron. It's 1. Calcium. Okay, I just put like this way, 3s2, 3p, um, 2p6, and then 4s2. So you have two electrons. You're going to use two electrons. C8. Sulfide is 3s2, 3p4. You have four electrons, so you can either lose or gain. Oh no, six electrons. You have to gain. Okay. Okay, using your knowledge established from question 2 and the charges of the ions, so sodium is Na is we are going to use the cross method, Na plus is 2 minus, so it's going to be Na2s. Calcium fluoride, calcium is Ca is 2 plus, chlorine is minus, so when you cross, you will get Ca. Um, Okay, question 4, I'll leave it up to you. Potassium and nitrogen. Potassium is K plus. You just consider nitrogen is N3 minus. So it's likely to be a 3K. So you have to make use of this to electron transfer. Magnesium oxide, magnesium is 2 plus. O is 2 minus. Then we do not write down Mg2O2. We just write down MgO because it's in the simplest form. Okay, so we do not normally write down like this because it's going to be 1:1. We do a simplest ratio. So what we write down is magnesium oxide. Calcium and phosphorus. Ca is 2 plus. Phosphorus is 3 minus. So if you cross it out, you will get Ca3p2, which is a calcium phosphate. The name that you're going to get, it will be a calcium phosphate. Any question? Okay. Okay, what is included after the name of a transition metal to denote the charge of the ion? So it's basically what we call it a Roman letter representing the charge. So we use Roman number. There's 1, 2, or 3 to represent the charge of uh, monoatomic ions formed from a single active two Okay. Form of electrons. So that is monoatomic. Polyatomic ions. Alcohol. Normally, H plus ions is called proton. Okay, later on, when we come over to unit 2, when we look at acid and base, and we have to recognize H plus ions is proton because H plus doesn't, hydrogen ion doesn't have a nucleus, sorry, neutron, it only have a one proton. So when you do not have a one hydrogen without an electron is just proton. Okay, so um, sometimes later on we need to recognize that this is also a proton. It's equivalent to okay, what is the charge on the ion formed by the non-metallic elements? Non-metallic elements that are present in the following group of the periodic table. Explain how you arrive. Group 2 is not non-metallic elements. Let me double check. Yeah. So it's going to be a 2 plus because you lose 2 electrons. This one is charge is 0. It's stable. Group 15, you need to gain 3 minus, gain 3 electrons. Group 14, it could be plus or minus 1, or rather, because group 14, you can either lose or gain. So it will be a 4 plus or minus because either gain or lose 4 electrons. Yeah. Sorry? 14? Is it 14? 14. Oh, no, no, no. It's if it is, they will actually skip losing coming back to here. I mean, but normally most of the case, but they are quite stable. So in this case, mostly they do not change. Mostly they do not form ions. So this is a very rare case, very rare situations. Question 8 is just a formula. Maybe let me try to just bromine. Bromine is Br minus. So lithium is Li plus Br minus. So you will get lithium bromide. Calcium is Ca2 plus is Cl minus. So they will form KCl2. Magnesium is Mg2 plus. And S2 minus. That will give you MgS. Aluminum is Al3 plus. As you know, I have written down for hydrogen carbonate, which is an HCO3 minus. So if I'm going to cross, because you have to consider this one as a single entity, you will get Al HCO3 twice. Ammonium is NH4 plus, and SO4 is 2 minus. So when you cross, you will get NH4 twice and SO4. So this is going to be an ammonium sulfate. Nickel 2, Ni2 plus, and then phosphide P is 3, right? Oh, no, this is phosphide. It should be phosphate, not phosphide. Okay, if it is phosphide, is 3 minus. So it's going to be Ni3P2. But there is, I think it's a typo error, probably. Here they are looking at phosphate. It can also be a nickel phosphate. Oh yeah, this is what I got to mention. Phosphate is PO4 3 minus. Let me finish this. Okay. No, it's we have 3 accents, so we need to record. Okay, so nickel, if it is a nickel phosphate, it is going to be a Ni3. Vanadium nitrate is NO3 minus, vanadium is V3 plus. So it is going to be a V NO3 twice. This is, I think, is the last part that we're going to look at to name them. Let's try to name them. This is a sodium, hydrogen, eight. This is net. We have a 4, so it's a net 4 nitrate. This one is cobalt 1. Cobalt is a transition metal, so you need to write down its valency. This one is lithium phosphate. This one is iron 3 nitrate. This is ammonium. It's a other hydroxide. Yes, bottom right. And this is iron, because the valency is 2, this is iron 2 bromide. And this is going to be a chromium. Oh. Chromium chloride. Chromium. Beside that, name for this. Okay, so these are all the names that we need to know. Yeah, we can still like put bracket or without bracket, doesn't really matter. Okay, you can put bracket or without bracket. Okay. So okay, namings, formulas. Okay, I'm gonna return you all your tests because today it's also quite a number of absentees and I was still waiting for 2 papers to come, so I'll return this one next week. So definitely next week I'll have to return to you. Yeah. So I think if you don't have anything, so I may stop here. You do not have any homeworks, but I need you to read 4B in advance. The notes is quite simple for you to understand. So please read that one. The notes is given to you next week. Then we'll do the exercise along the way that we'll do it. So next week probably we'll finish this. Okay, so next week we'll be focusing on the structure of this ionic compounds and how does it affect its physical properties. All right. Okay, so in that case, we'll stop here. Thank you very much.